All right, let's talk about graphing polynomials. So in front of you, we've got a third degree polynomial, and I would like to draw a rough sketch of this graph. So what we are going to do is we're going to build a table, find some points, and then plot those points, and then check ourselves to see if that makes sense, right? So function notation, that's f of x, allows us to plug in values and then get something out. And that something that we get out is the f value, or really what it is just the y coordinate. So if I plug in 1, what I get out is the y coordinate at that 1 value. And what I can use that to do is start to get a picture of my graph, especially if I plot, -2, -1, 0, 1, 2, and I start to get a picture of what my graph looks like. So let's first look at I'm going to build a little table to keep my values in. So we'll call it x and y. And I'm going to plug in 5 values centered around 0, -2, -1, 0, 1, and 2. Right? And so what that means is if I plug in -2, I'm looking for f of x, or f of -2, f of -1, f of 0, f of 1, and f of 2. So let's first look at f of -2. So to do that, what I like to do is put parentheses wherever I see an x. This keeps me from making mistakes with my negatives, and now I'm just plugging in -2 wherever I see those parentheses. And from here, you could simplify on your own. You could plug it into a calculator. So you'll notice that -2 cubed is -8, but there's a negative out front, which makes that a +8. -2 squared is 4, times 2 is also 8, and then adding 2, which would give us 18. So f of -2 is 18. So our first point that we would graph would be -2, 18. So I'm not going to show the rest of these, but we could go over to Desmos and build a little chart. So let's do f of nope, sorry. And we're going to raise that to the third. All right, so I'm not going to show us the graph yet because I don't want us to have any preconceived notions of what our graph should look like. We're just going to use this to check and generate solutions. So we can check ourselves if we wanted to check that f of -2, well, we get out 18, right? So we can do that for all of our values. So let's instead try -1. I get out 5, so I'll write that down. If I plug in 0, I'm going to get out 2. And the reason I know that is because 0 will 0 out the x cubed and the x squared, which will just leave us with 2. If I plug in 1, that'll give me out 3. And if I plug in 2, I'm going to get out 2. All right, so now what I have is 5 points, so I can start to build a graph. It doesn't have to be perfect. Really all I want to see is what's happening in the middle of the graph. Where are those turns coming in, that sort of thing. So we'll draw a rough coordinate plane. And we'll just do that's -1, -2, +1, and +2. And then the y values I'm gonna approximate a little bit, obviously, because we might have some scaling issues though there. But first point I want to plug in is -2, 18. So I go to -2, and then 18 is just going to be really high, so I'm going to put it up at the top here. Next point is -1, 5. So I'll plot -1, 5, -1, and then 5 is about a third of 18, so we'll just go about there. And then we go to our next point at 0. We want to go up 2 units, which is about half of 5. We'll go there. At 1, 3, we get out a 3 for a y value, which is a little bit above 2, so I'll put it slightly above. And then at 2, we've dropped back down to 2. And so now I've got a picture, and I can draw a graph through those. So I'm just going to connect them sequentially. And the last thing we'd want to do is extend out our graph. Right, so on the left side here, it looks like it would probably continue going up in this direction. And on the left, it started to turn down, so we're going to continue moving in that direction. So what we have now is a rough sketch of what our graph would look like. All right, so let's go check and see if that's the case on Desmos. So if I turn, if I let us see this graph, right, that is exactly what we got. We had a little bit of a turn there in the middle. It was a little bit stretched out sideways, but nonetheless, hopefully you guys can see that essentially we had the same shape. We had the same number of turns, that sort of thing. So that's how I would go about rough sketching a polynomial.